Well, welcome to this next tutorial on nowRail, and today we're going to be looking at making control panel LEDs and Neopixels. So if you remember the last tutorial, let's just switch over to the webcam. In the last tutorial we got as far as using the GT911 touchscreen. And today we're going to be aiming towards building the full system with, in this case, background Neopixels. But I'm also going to be showing you over here how you can use LEDs in a number of ways instead of the touchscreen and Neopixels. So let's get started. So the first thing we need to do is understand how nowRail works. Now, when you have your control panel, and I'm thinking now, GT911 touchscreen or buttons, stud and probe, whatever you want to use. This sends out a command over the ESP now to the accessory controller. So this would be the unit that's going to move your servos or your solenoids or whatever. Now what happens is when that accessory command is sent, there are two responses that are sent back. One is a response to tell the control panel not to keep repeating the accessory command, but there is another response that is sent that is separate, that is called a panel command. And a panel command is a broadcast to any control panels to let them know that a certain accessory has successfully moved its, or at least received the signal. I can't guarantee that your solenoid pump to work or whatever, but if you like, the system has tried to trigger that accessory, and it's now sending a response back to the control panel to say, I have now done this. Now the reason it does it this way is if you had a number of control panels, all of them will receive the update, so all of them can update their panel status. So to show you how this works, let's hope this works as an experiment. Let's just touch a single point and we've got a command that's come through. So zooming in, let's take a look at this command. So the first thing that happened is we see an accessory command was sent out for accessory number 112, and the instruction was to move to position 0. We've then got within the unit, it actually dealt with that because it's moving a servo, so it's using a PCA 9685, and it has received that instruction and it's processed it. Then what it has done is it has sent out an accessory command response. So this is that response that goes back to the original sending unit to say, I've got the message, don't send me any more reminders, because nowRail, if it doesn't get through first time, is going to send 5 reminders. Then we see this next command that's sent out, which is the panel update broadcast. So again, it's sending out the same accessory number and the same direction, and this is then transmitted out to the various control panels. Now the reason for building the system this way was I wanted a method whereby control panels could be built very easily with the minimum of programming. So what we're going to look at first is what is called in nowRail standard pin functions. Now a standard pin function is a pin that is used directly off the ESP32 or ESP8266 board. So if we look up on the top corner here, you can see I've got 4 LEDs plugged in, and they are connected through these resistors directly to the ESP32. So let's have a look at how that works. So jumping down to the standard pin functions, we have got standard pin LED functions. Let's just get rid of that camera for a moment. And all that happens here is we need to put a pin number from the board, the accessory number, and the direction of that accessory that we want this pin to respond to. Now, one of the things that's different here between a normal accessory command is that when the system receives the correct command, so I've got an example here, so we're saying that pin 15 is linked to accessory 100 and will respond to a direction of 1. So when it gets a command of 1, this pin will go high, therefore the LED will light up. However, if the command is the opposite, if it gets a 0, it will automatically turn this LED off. So the user doesn't have to worry about how that's done. So let's have a look at how that's set up in code. So zooming into the demo that I've already written, we can see that in the setup, all that is required for a standard pin function is literally to put the details in. So I'm using pins 14, 27, 26 and 25, and as you can see I've got an LED that I want to light up when the direction is 0. I've then got an LED that I want to light up when the direction is 1, and then I've done exactly the same for accessory number 101. Just repeat the code. So let's have a look at how that works. So going back to the webcam, if I click the one direction, you'll notice I get 2 LEDs changing at this point. This is because this center point is sending out an instruction to change 2 accessories. So if I then click the one here or the one here, you will see that only one LED changes, but that center point changes 2 of them. Now you'll notice I've also got this being replicated down here, and I'll explain why in a minute. But it really is that simple to set up your sort of standard pins. Now, much as standard pins are the easiest way to add panel LEDs, the big issue of course is you can only have as many LEDs as you've got pins free on your board. So if you need more pins, and let's be honest, some control panels need crazy numbers of pins, then we go to these functions, which is the 74HC595N shift register pin functions. So let's jump down to that. Now there is a wiring diagram of how to wire up shift registers. Shift registers can be shared between accessory command and panel commands. It might sound a bit weird, but you can actually have the same one board controlling accessories and being a control panel at the same time. nowRail really doesn't care. So this is the wiring diagram for it. You can attach multiple shift registers, and there is a video here, it's number 77, which goes through a little bit more information on using shift registers. Now going down a little bit further to the function that we're after, the function that we're now looking at is add 74HC595NP panel LED. And it works basically the same way as the standard pin, except this time we connect to a chip and a pin number on that chip. So with the chip numbers, chip 0 is always the one connected directly to the ESP32 or ESP8266, whatever you're using. Chip 1 is the next one in line, chip 2 one after that, and obviously you can add multiple chips. So basically you can add as many contacts, so as many LEDs as you want. Obviously you will need a separate power supply if you're going to start running loads of these things, because otherwise your ESP32 is not going to be able to supply the power. Right, let's get into how those functions are put into code. So once again we're back in the setup, and all that is required in the setup, obviously we've seen how to attach the standard pins. Everything that is put in here must come under my layout init. And then we get to setting up the shift registers. Now let's zoom in so we can see the code a little bit easier. So working my way up. So what we do first is we initiate the first 74 HC595N, and we do this by passing it the pins that it is connected to. If we go back to this diagram, basically we're sending it the clock pin, the data pin, and the latch pin, and that is done in the function that we've got here, which is basically the setup. Now once that is set up once, that covers all of these chips. So going back to our code, once we've done that, then it's just a case of setting up the individual LEDs. So I've only got one chip, so obviously the first line is going to be 0 if you were using multiple chips, you know, chip 1, chip 2, chip 3, and then it's the, if you like, the pin on the chip that you are attached to. So I'm using pins 0 to 3 on chip 0, and then what I'm doing is saying, you know, very similar to what I did above with the standard pins. Basically I've repeated it and said if it's accessory 100 and direction 0, I want this pin to light up. Otherwise, if it's direction 1, the other pin, and working down. I only did a few examples just to make life easy for myself. So here we are once again back at the breadboard, and again if I click the center button, you can see that 2 LEDs change. That's because 2 panels, 2 items have moved, and obviously I can reset these things as I want. Now where I've got 2 moving at once, obviously you don't have to set it up like this. You could save on pins, but I just wanted to sort of give a demo of exactly how that was going to work, because obviously in reality these could be 2 separate points that are not sort of connected in this way. Now the other thing you'll have noticed as I'm pressing these, on this strip here we have Neopixels, and that's what we're going to look at next. Now when I started to write the nowRail system, I wanted it to be as open as possible. So I wanted standard functions, but I also wanted people to be able to add their own custom code. So the Neopixels are not built in as a function within nowRail. All I've done is I have used the standard Adafruit library. Let's just zoom into that so we can get a better look. So I've included nowRail, I've sort of set up nowRail, and now in these lines I've just connected the Adafruit Neopixel library. Then what we do is back down in the setup. This is the function that initializes Neopixels. We've then got a function to clear, that clears everything. And then what I do, this is something I've always done with Neopixels on my control panel, I actually set them to blue. And then you've got, so once I've worked through the 5 Neopixels in my demo strip, I set them all to blue, and then this command pixels show displays them basically as blue LEDs. This, if you like, sends the data through. This tells the system when to switch that new data on. So that's what it does when the system sets up. Now it's one thing setting up the Neopixels and just setting them to a color, but obviously you now need them to respond to the panel commands as they come in. And what you do for that is you go to the Custom Functions tab, and there is a function called nowPanel Update, and it just gives you the accessory number and the instruction. This function is called from within nowRail every time a panel update is received. So whatever code you put in here, and this is one of a number of sort of custom functions within nowRail. You've got similar things for accessories if you want to build your own accessory code, but this one is specifically for panel updates. So it receives an accessory number, it receives an accessory instruction. By default there's a serial print command just to show you what on earth is coming in, and then all I use is a simple switch statement. And if we look at this switch statement, it's for accessory address 100. I'm then setting the one Neopixel to red, the next Neopixel is sent to green, and then I show it. And if the opposite direction was selected, it does exactly the same, and that then goes down for accessory 101. So if we go back to our webcam, we can see as I touch these things, you can see the Neopixels changing color in exactly the same way. So as you can see, setting up panel LEDs, whether you want to use Neopixels or LEDs, it really is up to you. There are advantages and disadvantages with each. Neopixels, I think, possibly a little bit easier to wire up, however they are big, which means you just cannot, you couldn't have small close together buttons in the way that you could with LEDs. So now what I'm going to do is show you how I made the big control panel. Now, one feature just before I show you the exact build of this particular unit, I just want you to watch carefully. I've got accessory 100 and 101 down here. Now if I click this accessory, you will notice the LEDs are changing on here, the Neopixels are changing on here, but they also change on here. Unfortunately not too well, because I've only got, these are for a traverser, so they don't have a left or right. But if you notice, the updates are going to both, and if I click on these ones, again you'll see that both panels update. This is because in this particular situation both are on the same layout address, and these could be two control panels at opposite ends of a layout that are both sending commands to exactly the same accessory decoder and are both receiving panel updates to say that something happened. So that is why the panel update is separate from what I would call a standard accessory decoder system. So this is the basic construction. On the top layer over here you have the GT911 touchscreen right on the top. That is then mounted over a piece of Perspex. This is quite thick Perspex, but I'd been given it and it was free, so that's what I was using. And that in turn sits on top of the Neopixels. Now, if I was doing it again and having to buy the materials, I'll be honest, I would have used slightly thinner Perspex. So what I then had to do, this is an old version of one of my prototypes I built. You can see it's actually built on wood. So I basically took a piece of plywood, painted it black, stuck the Neopixels on here. Obviously you've got to work out where the beginning is and work your way through, and then of course here I messed up because I added some extra bits later. All fun and games. And then on the back, basically it's a piece of Veriboard. The GT911 touchscreen plugs in here, the Neopixels come out of here, and the ESP32 fits in here. Now on these later ones, it's exactly the same except all 3D printed. Basically identical, just looks a little bit neater. You'll notice I put bits of coloured nail varnish on here. That's just that I know I'm getting, which is my positive pins and stuff like that, so I don't make any mistakes. This one, when it's in operation, there is a pin that plugs in here that goes into a USB connector that is fitted in the base, and going forwards I'll probably put some LiPo batteries in. But that is realistically how this thing works. And so for the traverser, you know, normal points, it's easy. You want on or off. With the traverser, it's a little bit different because it's got 5 different positions. So as I touch the traverser, obviously one light goes green, but I want all of the other lights to be red. So the traverser, you know, that's how it all works. Again, I've got that situation where you have a turnout here, a turnout here. If I press the center one, the outer ones both go to red. If I press the edge one, this point both goes to red. I've always done it that way just because it gives me a warning that I am not sure at this point what is this turnout will still be turning towards the center, but obviously the track at the other end is not available, so it goes red on both outputs. So let's have a quick look at how the code was written for that. So the way this was written, obviously the Neopixels, as we've seen in the previous bit of the video, very simple. I just used the Adafruit library. I've connected in this case to pin 13. That's because that's the way that that unit had already been built, so that's the pin it's connecting to, and I have 18 Neopixels on the row of Neopixels. Going down to the setup, we've got a number of items in here. Obviously we've got the layout initiation, and then we've got the GT911 screen. Now, to use the GT911 screen, you need to go into the user setup and just uncomment GT911, the address of the board, the number of touch buttons and the touch radius. Again, that's all been covered in a previous tutorial, so I'm not going to go into that in detail. Once you've done that, then as I showed in the previous tutorial, it's just a case of setting up your individual touch points. So I've got touch point X 101.5, Y is 524. That's going to control accessory number 100, and it's always going to want to move the turnout to direction 0. Again, all that's been covered in the previous video. Then after I'd added all of those buttons, and this didn't take very long, it took me about sort of 15-20 minutes to work through it all. The next bit then was my usual startup. So the pixels have begun, I've cleared them all, I've set them all to blue. Basically I've worked through, you know, in a loop, and I've shown them all as blue on startup. Again, the reason I do that is so that when I turn the layout on, I know that I don't know the direction of any of the turnouts. So it means I've got to start pressing buttons to make sure that I've set a direction. Then obviously I went to custom functions and used the now panel update in exactly the same way as I showed you before. In fact, when you look at the sort of normal accessories, you can see exactly the same bit of code. You know, some LED, some Neopixels of a certain number. This is the number on the string, having their colors set. However, for the traverser, which was those 5 linked together, I give each position on my traverser an individual DCC address. That's just the way I use it. My traverser is still running as a DCC decoder, so this actually passes the instructions for the traverser to DCC-EX, whereas for the various other points it sends the information straight to nowRail. That's because the traverser has been constructed some time ago, and I'm not going to rebuild all the control systems for that. But what it actually does from a display point of view, you can see that it's setting one Neopixel to green, all the others are red. When it goes to the next position again, loads of reds and one green, and so it works through the system. And that's basically it then. You just work through your various accessories one at a time. I just sort of, one sort of Neopixel at a time, work through it all. It took me probably about 20 minutes, 25 minutes. What I tended to do is get the red and the green back to front, did that quite a few times, but again, it didn't take very long to finish it all up. Now obviously I use Neopixels because if we go back to the web camera, I don't have many turnouts on here, so I've got plenty of space. But you know, you have to be realistic. If you're looking at the way this is set up, this is as close as you can get your touch points. So if you want a huge number of touch points, realistically you're going to have to use LEDs, or if you want the colors to change from red to green, then you can just use bicolor LEDs. nowRail will support either feature. Anyway, I hope that's been useful to you, and if it is, please click the like and subscribe, and I'll get the rest of the sort of tutorials on the nowRail system out as quickly as possible. So bye for now.